Okay, so today I want to talk about endogeneity and one new method, which is the method of instrumental variables or two-stage least squares. So after our nice interlude of machine learning, where we didn't have to think about causality anymore, or even about coefficients, because we were all about protection, I want to bring us back to our efforts to establish causality, which sometimes is really what we are interested in. So suppose that we start from a model like the one we had finished with at the end of last lecture, where we have some x1 variable that we actually observe. We are interested in the causal effect of x1. And then we have some x2 variables that we may or may not observe. And we discussed a bunch of stuff that we could do in order to make sure that the coefficient of beta 1 is in fact indicating a causal relationship going from x1 to y. But there are occasions where the regression-based methods that we saw, just controlling for as many x2 as we can, or a difference in different strategies, which is another form of regression control if you want, or even regression discontinuity design, is just not going to cut it. Because we don't have the control variables, for example, because there is no regression discontinuity that we can use, or because a plausible case can be made that the variable x2 actually could affect y. The variable x1, sorry. x2 also, by the way, but here we are interested in causal effect of x1. The variable x1 might affect y as well, in which case it is really not an easy control approach to that problem, because if the variable x1 affects y and y affects the variable x1, like there's no way we cannot easily control for that. So Sarah gave me a very nice example of this, which is this kind of breaking news of a few years ago: unhappy people watch more TV study. An extensive new research study has found that unhappy people watch more TV, while those who consider themselves happy spend more time reading and socializing. Now the question is that from this title, do you think they are trying to claim that it is TV that makes you unhappy, or that is unhappiness that makes you watch TV?
The latter.
The latter? Who is voting for the former? No one. So interestingly, they are actually thinking about the former and the latter. This is a spectacular study that actually, in the same study, which is based on correlation, makes both causal claims. TV does cause people to be less happy. In other words, the causal order is reversed for people who watch television, and happiness leads to television viewing. So I think one could actually make a reasonable case going both ways. So it is not necessarily a stupid thing to think about. The problem is that intuitively you feel both could not very easily being established from the same causal regression, because if I can write the model both ways, clearly the coefficient is going to be biased if I first attribute the entire causal effect on x, and then I reverse the regression, I attribute the entire causal effect on y. I seem to be giving myself double credit. So that's the main problem from endogeneity, is any situation where they're making the argument, actually, a sort of a theory argument, why TV causes people to be less happy, which is the idea that it's too easy and it's passive and you don't other activities have more benefits. And then the other, so that's why TV might make you unhappy. And in other words, the causal effect is reversed. Unhappiness leads to television viewing. If you're unhappy and not very energetic, you're going to watch TV. So both channels are plausible a priori. So this is when we have an endogeneity problems. so we talk about endogeneity when there is this mutual relationship. What are other examples that you can think about where you'd have, it's not an omitted variable bias, it's really the fact that one could sit down and write a model, a causal model going either way. So can you think of other examples where we would be in the same situation? Yep.
A lot of conditions associated with state failure would sort of have mutually reinforcing effects, whether it's like type of government leading to state failure or state failure sort of being associated with particular types of government.
Right. So for example, you could have, that's a great example. So you could have huge crisis leading to a government like collapsing, or you could have the government collapsing leading to a huge crisis, and those two things we'll observe them together, and what caused what, maybe both caused each other. So that's a great example. Yep.
Any system with a lot of feedback, if it's a type of temperature controller, for example, the temperature itself is a job by itself.
Right. Yeah, that would be
for example, if you say that a low socioeconomic status leads to tends to be associated with lower education, then lower education is also sometimes related to lower socioeconomic status.
Right. So one thing here is that it might not be, if you're interested in the economic status of the parents, might lead to low education of the kids, and then the low education of the kids will not immediately necessarily feed back onto low education of the parents. So in that case, that might be more of an omitted variable bias. But you could think of version of that, for example, older teenager running into trouble at school, getting kicked out, which only brings them to more trouble, which.
Practicing something, say an instrument makes you better at it, and being better at it makes you want to practice it more.
Exactly, perfect. So these are all great examples. So related to the state failure, it's sort of democracy and growth. Maybe growth makes it more plausible that the democracy takes hold because there is more interest in a participatory process of government. On the other hand, maybe democracy is good for growth. There is a paper on the flashing everywhere in the department these days that makes exactly this claim. Health and exercise is another one. You could think that exercising regularly keeps you in good shape, but if you're in bad shape, you might not feel like exercising. Recent one that I heard about is that people who do crosswords are less likely to exhibit sign of cognitive decline, like pre-dementia. On the other hand, you're messing that people who have pre-dementia are not so excited about doing crosswords. So and of course, one that as economists we love is prices and quantity. When prices are low, people want less of it. On the other hand, when people want more of something, the prices tend to go higher. So in this case, it's actually the relationship going in opposite direction, but there is also a causality running both ways. We can run the equations. There is a supply equation and a demand equation where price and quantity appear on both sides. So these are examples of endogeneity. So whenever we have endogeneity, we have a problem. It's going to be difficult to come up with a control coming from out, using the strategy of adding a lot of x2s or even a difference in difference once there is endogeneity. And then there are also many cases where there is no, strictly speaking, endogeneity, but there is just a very thorny omitted variable bias, and we know that there is no data set in which that variable is there. It's not an endogeneity. We could even name and pinpoint the variable if we could, but we just don't have it. And I'll give you one example of that that's going to be our sort of running example for today, which is the benefits of education. Exactly the example that you mentioned. We know that there is a strong correlation between education and many outcomes. Of course, knowledge, earnings, fertility, that's mostly in developing countries, but health, etc. Of course, if we observe, if we interpret, if we run a regression of any of these outcomes on education without controlling for a number of stuff, there might be bias, exactly as you pointed out. For example, the family background might affect those outcomes later in life. Kids who come from poorer backgrounds may have trouble finding a job for reasons of nothing to do with education, but say because of networks, and for this reason they'll have lower earnings. So that's going to create an omitted bias, variable bias, and it might be very difficult to observe everything we need to know about the kids. Another one is just what we were discussing in case of the applying to college, sort of spunk and drive and energy, what economists sometimes put under ability, which is a little bit vague, but people who are more energetic, etc., smarter, whatnot, will find it easier to get an education. They might also do much better in life anyway, even without the education. There are cases like the cases with the college application where we have a variable that's a pretty good proxy for that, but it's rare. You have to be, we were quite lucky to have that. So in this case, my first instinct to any such problem is to see whether we could run an RCT, but in this case, assigning education to people is not going to be possible. Because an education is really a choice. You can't really force kids to stay in school past a point. You can't, and on the other hand, you can't force parents not to send kids to school. So that's, it's closely linked to your personality and your choice and who you are. So let's say we cannot assign randomly. You get 3 years, you get 5 years, you get to go to secondary school or not, okay? Let's say we can't really do that easily. So what can we do? Well, instead of trying to assign education randomly, we could try and assign students to a program which may lead her to get more education. So what would be an example of an education of an intervention like that could be randomized, that is going to lead some people to get, on average, going to lead some people to get more education than if they had not received that particular intervention.
After-school programs where enrollment is designed at random.
Yeah, so it could be an after-school program for reasons. I want you to keep this thought in mind because for reasons we're going to discuss in a minute, it's not going to be a great instrument, but it's still going to, it could still affect whether the kids stay in school. So let's keep after-school education. Yeah.
What about free preschool?
Right, so free something would free preschool or whatever level you're interested in, free preschool or free school, yeah.
Free meals.
Free meals, exactly. So let's keep that in mind as well.
Campaigning, advertising.
Campaigning, information, etc. Try to convince, for example, there is quite a lot of evidence that parents may not be aware of the benefits of education. So letting some people know what the benefits of education are could be a way, yeah.
Access to technology like a free laptop program.
Right, I want you to keep that one in mind because it's also going to create problems for us, but that could affect education, Holly.
I'm not sure if this one fits, and that's why I'm asking, but what about regular public school versus a charter where you have to get in by lottery?
Right, so that is going to give us the effect of going to charter school as opposed to the effect of regular public school, which is a very interesting and important question on its own, but would probably be a different question.
But that's not exactly.
That's not exactly, because now I'm thinking about something that's going to vary whether, the years of education literally that some kids get. Yeah.
Rewards for attending school or for high performance.
Right, you could give incentive. There again, I want you to keep that in mind. We'll go back to all these instruments. So I hope you can maintain a mental list of all of the ones, because I want to go back and reevaluate them. The one I want to study today, so for now, the one I'm going to keep track on immediately is Lisa's idea of scholarships, making education free for some people. But whatever the intervention is that is going to affect education, if that intervention has no direct impact on earning, if we're willing to make the assumption that intervention in and of its own would not affect earnings or cognitive scores or whatever you look at, but you see that it affects earning, that the people who got the program are have higher cognitive scores or have higher earnings or have lower fertility, then you can infer that because if you're willing to make the assumption that it has no direct effect on education, then you can infer that if affected earning, it has to be because it moved education. So in other words, there is a link between the intervention. So here I'm going to call it scholarships affects education, which affects final outcomes. I'm going to write a number, cognitive score, earnings, attitude, etc. Suppose that you are willing to make the assumption that that link is not there. And suppose the scholarships were randomly assigned such that you can really look at the effect of the scholarships on cognitive scores or earnings or attitude in a way that you're really convinced it's a nice causal effect. Then you can say, well, I see that scholarships affect earnings, that the people who got the scholarships have higher earnings than people who didn't. I'm willing to assume it's not because of the scholarship themselves, then it has to be because of education. And because of that, I can infer what the effect of education is without really using any endogenous variation in education. So that's basically the name of the game. Now I'm going to formalize this insight. So if it went fast, don't worry about it. We're going to now go very slowly through this. We are using a scholarship as an instrument for education, which is something that makes education move, that we can exploit in order to look at the causal effect of education. So that's the plan. So I'll give you, and we are going to do that today with an example that I worked on with Pascaline Dupin and Michael Kramer, where we actually randomly assigned scholarships for secondary school. So the question we want to look at is whether education affects cognitive scores and wages. Write YI as the outcome. For historical reason, I call AI the education. So that's our education outcome. So in this case, it's going to be whether the kids attend secondary school or not. A dummy variable equal 1, whether the kids attend secondary school or not. And Y is earnings or cognitive scores. I'm going to do it with both cognitive scores and earnings. And I'm not willing to make the assumption that that epsilon I is independent of AI. That's the big difference between the setting we have now and what we looked at before. Because in there is an omitted variable problems. I don't have the variable, which is ability or spunk or network connections or whatever goes with the background. So in the absence of that, I know that if I estimated this equation, it would be biased. Beta would be biased. One note, this assumes that the effect of education is the same on all people, on everybody. So there is a coefficient beta. We may not like this assumption because education might be more effective for some people than some others. So we'll discuss how to interpret IV when that assumption is not correct in a bit later in this lecture. But this is a model that should be familiar after all the econometrics we've seen. And we're really interested in a causal estimate of beta. So what did we do? We went to Ghana, where primary and junior high school are free. Then there is a big gateway exam after junior high school. And you can only go to secondary school if you qualify. But in addition, it's very expensive. So it goes from, you go from free primary and junior high to very expensive secondary school for people who qualify. So what we did is we went to a bunch of kids who had qualified but had not enrolled by September. And we could know that by looking at, going back to all the junior high school where they attended and find out information about them. We had this way a big set of kids who had qualified for secondary school but didn't go. And it's pretty common in Ghana to show up late in secondary school, to show up in January instead of September, because you manage to gather the money. So what we did is we went to see them in September and say, hey, so we took a sample of about 3,000 kids, and we randomly selected about 1,000 of them, and we went to say, hey, if you want, we have a scholarship for you to go to secondary school, for your, which is going to cover the 4 years of secondary school. So I want to call this variable zi, which is dummy equal to 1 if you are assigned to the treatment group and were offered a scholarship, and 0 otherwise. So this Z1 is randomly assigned because we randomly selected in our little office who we would go with saying, hi, can we collect some data about you? Or hi, can we collect some data about you? And then, oh, by the way, we have a scholarship for you. And then what we did is that we followed them. So we did that in 2008. And we've been following them since then. So first, we had to wait till they left school, so which they did in 2012. And then since 2013, we've been interviewing them regularly, both the losers of the scholarship, the people who didn't get it, and the winners. So getting the scholarship does not translate into a one-to-one relationship between going to school, because most of people who got the scholarship did go to secondary school, but not everyone. Some of them, by that time, decided that they were not interested anymore. And on the other side, a bunch of the kids who didn't get the scholarship managed to find some other way to pay for secondary school, so they cobbled the money together, or they got some other scholarships or something like that. So what we have here, and that's going to be the structure of the table for a lot of today, is we are looking at boys and girls separately, and we are looking at their outcomes. So this is the average, the sample average in the treatment group, in the control group, the difference with the standard error, the sample average for the treatment group, control group, the difference with the standard error. And what you see is that, so first of all, it's not going to mean anything to you, but give me a moment of admiration for the fact that we found back 97% of the kids in 2013. We found back 97% of the kids that we had identified in 2008. And remember, adolescents are mobile because this is the moment where they will leave and go work elsewhere. So that was a pretty good tracking rate. It's important because when you don't track people, especially not equally, the people who remain are not necessarily representative of the initial population. Okay, so here we don't have that problem, so we can now forget about it. And then we can see that 78% of the treatment group ever enrolled to secondary school, and only 45% of the control group, of the treatment group. 58% of the treatment group completed primary school, 24% of the control group completed primary school. So that gives us a difference of about 33% for the women and 38% for the men, similarly. You see that more women didn't go even though they got the scholarship than men. And almost all the boys basically took a chance to get the scholarships. So we get this difference. And this is really the causal effect of getting the scholarship and going to secondary school, because that was randomly assigned. So that's nice. Now I want to combine this equation, which is the causal, my causal effect model, to with this data, which is the fact that the scholarship did cause some people to be more likely to go to secondary school. So let's combine the two with the expectation notation that we introduced when we talked about causality. So the effect of the treatment on participation can be measured by the expectation of going to school given that you got the scholarship minus the expectation of going to school given that you didn't. So for example, for girls, what is this difference? What is this number, this difference? 33% exactly. So now we can look at the effect of the treatment on cognitive test scores, or whatever you're interested in. I'll show that to you in right away. This is still cognitive outcomes. That's cognitive scores. Total standardized scores over here. This is standardized to be, it's in standard deviation of the overall distribution. And you can see that for women in the control group, they perform less well than boys. So they're in the control group, they have a standard deviation of minus 0.17. In the treatment group, it's about 0. So the difference between the two is 18 standard deviation of test scores. It's just a unit of test scores. 18 standard deviation for the woman. And for the men, likewise, we see that the treatment group is 0.30 standard deviation. Control mean is 0.18 standard deviation. So the difference is 0.125. So that gives us the effect of the scholarship on test scores. And we know, again, this is causal effect because our scholarships are still randomly assigned. So this really is the causal effect of winning the scholarship on test scores. But of course, that's not the effect of education on test scores because the difference is not 1-for-1 between getting a scholarship and going to school. So we could be interested in just that. You know, if I go around and offer people scholarships to go to secondary school, what is going to be the final impact on test scores or wages or anything you're interested in? Sometimes that's what we are interested in. But it is not necessarily the question of interest because, for example, the government might be interested in other ways to expand access to education, for example, building more schools or making it cheaper, etc. So you might be interested in the causal effect of actually going to schools. So now let's see how we can combine the fact that we have an effect of scholarship on going to school and an effect of scholarship on test scores to look at whether we can get a good estimate of the causal effect of going to schools on test scores. So for that, let's combine these two expressions with our expression for yi. So we know that y is alpha plus beta ai plus epsilon I. So I'm just going to put expectations around that for the treatment group. So the expectation of yi given zi equal 1 is alpha plus beta, the expectation of ai given that zi equal 1, plus the expectation of epsilon I given that zi equal 1. OK? I can do that. I'm going to do the same thing around for the control group, so just putting expectation around the structural equation. E of ei given yi given zi equals 0 is alpha plus beta e of ai given zi equals 0 plus e of epsilon I given that zi equals 0. OK? Makes sense? So I'm going to take the difference between the two, which is going to be our causal effect of test scores. What is it equal to? It's equal to beta times e of ei given zi equal 1 minus e of ai given zi equal 0 plus e of epsilon I given zi equal 1 minus e of epsilon I given that zi equal 0. Now, I want you to assume that this is 0. And we will comment on this assumption in a minute, whether it's a good assumption to make or a bad assumption to make. But for a minute, I admit that this might be 0. If that is 0, then beta is simply the ratio between the causal effect of the scholarship on the outcome of interest and the causal effect of the scholarship on going to schools. So this is what we have here. Beta hat is e of yi given zi equal 1 minus e of yi given zi equal 0 divided by e of ai given zi equal 1 minus e of ai given zi equal 0. In other words, what I'm doing is that I'm scaling up the effect of the scholarship by the fact that not everybody is induced to go to school because of the scholarship. Some would have gone anywhere, and some didn't go even despite that. So in our example, this would be for women 0.125, if I remember correctly, divided by 33%. So basically multiplying by 3, so it's going to be about 0.6 for test scores. So it's telling me that people who have gone to school have cognitive test scores that have about 0.6 standard deviation higher than girls who haven't gone to school. Okay? So the key, of course, of all this calculation is this assumption over here that the expectation of epsilon I given z equals 0 minus the expectation of epsilon I given that z equals 1 is in fact 0. So why is that possibly true? And that's going to tell us basically for an instrument to be a good instrument, we need two things. This better not be 0, otherwise this is going to go to infinity, and with it the standard error. We need something that affects the first stage. We need a relationship between scholarship and education. That's easy to check. If it's not there, you just try for another instrument. So that one is pretty important, but pretty fundamental, but easy to check. The other one is that is this assumption that the expectation of epsilon given z equal 1 minus z equals 0 is in fact 0. And that really can be unpacked in two things. One is that the effect of zi on yi can in fact be estimated well. So that's going to be given. In this case, it's given to you free of charge because the instrument is randomly assigned. So we do know that the difference between the outcome for zi equal 1 minus zi equal 0 is in fact the causal effect of getting a scholarship on test scores or the outcomes. So that's one aspect. When we use instruments that are not randomly assigned, that are given to us by nature or by natural experiment or whatnot, it might have to be argued that this is in fact true. And then there is a second part of the assumption that is not given to us for free, even in randomized control trials, and that's very important to remember that, is that there is no direct effect of the scholarship on cognitive test scores. Otherwise, this wouldn't be true anymore, because part of the effect of the effect of the scholarship on the test scores comes not from education, but from another channel. So in other words, in here, if zi really belongs to this equation, then we would have an omitted variable bias if we don't include it, and therefore epsilon e of epsilon I given z equal 1 is not going to be 0 in this model. I can't assume that. So anything that we need to be able to assume that the scholarship don't affect the final outcome.
When you assigned the scholarships, did you say that they were randomly distributed? Because I'm just thinking, if a child receives a scholarship, they may think, oh, well, I'm receiving this scholarship because somebody sees potential in me, and they see potential in themselves, and then they get spunk.
Yeah, exactly. So I believe we did say so, but we were concerned about that, overconfidence, spunk, etc., that people feel like, they've been chosen somehow. By us or by God, for that matter, or and then that would have an effect independently of a scholarship. So we did look at, we tried to get at that, but you're putting, more generally, you're putting your finger on exactly the really hard part with IV is that you need to go over any number of those stories, and unlike the second assumption, which in this case is true by construction or can sometimes be checked, this assumption is has to be argued. So, and you will never be able to prove it. You can just think about all the stories you could possibly think about and try to see whether there is evidence for them. But you've never, so you could prove yourself wrong, but you're never going to be able to prove yourself right. So that's exactly that. And this is exactly what we need to never forget to chase both conditions, that there is no, that both the scholarship is randomly assigned or as good as randomly assigned, and that there is no direct effect. and try to go over in our head over all of these conditions, the second condition is often not verified, even when the first example here. So you ask the first question, which is, could the scholarship per se have an effect on cognitive score? Maybe the scholarship make people confident or happy, give them drive and spunk or energy. So that would be an issue. What else could be what could be another reason why scholarship have a direct impact on test scores?
Well, actually, maybe this isn't correct. Yes, not. But I was thinking because if the family has to like scrape up money, but now they have a scholarship, they can use the money to like for better nutrition, for example.
Yeah, exactly. So a lot of kids in the control school went to school anyway, and presumably they had to scrape the money. So now the some of the kids have gone to school anyway, but the treatment school didn't have to pay for it. Therefore, that money may not be used for buying books or buying better food or something like that. So that would be another reason why scholarship will affect your test scores potentially, even if over and above any effect on education, direct on years of education, which is what I'm measuring. Yeah.
Do we assign any value to peace of mind?
Yes, exactly. The students know that you scrap exactly 1 year, but you know that you need to keep thinking about it. It might stress you out. If you go to Sandilstoke today, it's like basically it's all about that we only have so much bandwidth to think about things in our life, and therefore, if I take some bandwidth away because you're thinking, will I ever be able to manage the money, you have less bandwidth to think about making good grades.
Did any of the kids who didn't receive scholarships work while going to school?
Not really, no, because it's like a lot of, you go to school, usually it's residential, so it's not that you have much of a choice. But if they had, then they would have taken time away from their study, and that would also be a concern. Yeah.
What kinds of survey questions have you been asking them in order to get at some of these other stories?
So anything and everything, like as many as possible. So first of all, I think it's a great teaching example, but actually in the paper for a long time, we didn't even present the IV because we thought there was a lot of things that one could be worried about. But since we were always doing it implicitly, we finally put it. But then we tried to put a lot of stuff to try to get at that. So for example, the other children, the education of the other children. For example, it could be that because you went to secondary school, you for free, it allows the other kids to get educated. So any notion of the budget constraint of the family being relaxed. We try to get at the overconfidence question by asking kids in advance of the cognitive test, how well they think they're going to do. People are very overconfident, boys more than girls, but it seems that the treatment doesn't affect that. We have questions on health. We have questions on how people paid for schools, etc. So, but this is all kind of always a little bit circumstantial. So that's the key. Yeah.
So in this process or this experiment, we're testing the effect of like education on test scores, but that's within people who were qualified for these.
In this group, exactly.
So does that mean that we have anytime we use this, it has to be with the caveat that like for people who are accepted to high schools, is there a way to generalize to like the entire student population?
So that's a great question. Strictly speaking, no. You've done the experiment here among a set of kids who qualified for high school anyway. So if the government is thinking about improving education by relaxing the requirement instead of making it free, so this could give us a good idea of keeping the exact system in place but making it free or cheaper. Right? That's basically going to cover it pretty much. What it would not necessarily cover is to say, keep the same amount of money, but relax or remove the admission requirement. Then you're going to get new kids coming in, but they're going to be different kids compared to this one. So that's a question of the external validity. So here the estimate is valid for this question in this sample, but if we don't assume that the returns to education are the same for everyone, they might not tell us the effect of another manipulation in another sample. And in particular, for example, you could think that admitting less qualified kids would, they would go to less good schools, might lead to lower returns to education. So what we did to try to address that is that we have kids over the entire distribution, because we have kids of admitted students, but some kids were at the very bottom and some kids are the very best because they were randomized at all levels. So what we look at to be able to say something to that is that the effect of the scholarship or the effect of going to school. Once you have one, you have the other, at all level of the distribution. Like, is it the case that we have lower effects for kids who are just qualified versus kids who are like well above? And we are not finding that. We're finding that it seems to be a shift up. So that doesn't necessarily mean that it would extrapolate beyond, but it gives you some sense that it might. Yep.
This is a general question, but how do you synthesize all the information that you get from surveys when you're constructing a model or a regression equation or something like that?
So that's a great question. Generally, when you conceive of a study, and if you're going to ask questions to people, you're putting a lot of questions in the survey, and therefore you might have a lot of, although it's less true for us because a lot of the surveys are done on the phone and have to be kept short, but one of them is in person and has lots and lots of variables. It has all of these, and then a very legitimate question is, what do you report? And the danger being that if you report many, 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 many things, I think we discussed that, if you run enough tests, a few of them are going to be significant anyway. So there are kind of two. The literature is, at the moment, in general, in economics and in social science, sort of grappling with this problem. One way to go is presumably you're running the experiment because you have a model in mind. You can write it up and therefore say in advance what you want to look at. So people call that a pre-analysis plan or registration. So you can say, out of this whole big wealth of data, I'm going to really focus on these 4 or 5 outcomes. That's what I'm mainly going to look at. And the rest is going to substantiate my case, but these are my litmus tests. So that is one way to go. And the other is to do the same exercise, but ex post, which is sort of write down a model ex post to justify what you're looking at, and then try to organize all of the things that you look at to make that case. For example, in our case, we really want to basically look at the effect of education on a range of outcomes separately for women and men. And then all of the rest is going to be circumstantial, that it's really the effect of education. So we can check for possible direct effect of scholarship on test scores that might not go through education. It sort of gives you some discipline for what you want to look at. But it's a great question. So that's it. So there's this thing is called the VALD estimate, the simple division between the effect of the scholarship on the final outcome and the effect of the scholarship on going to school. The nominator is the first stage relationship. Numerator is the first stage relationship. The denominator is the reduced form relationship. We call it the reduced form relationship. And the beta hat is the VALD estimate. And it's the simplest form of an instrumental variable estimate, where Z is our instrument. And it's simple because Z is binary, so we can just compare treatment and control. If you have understood this and all the subtleties that go with it, you're done in the sense of having understood IV, and the rest is kind of building up on this insight. We went through this quickly, but without the benefits of the table. But remember, this is the effect for women, for example. This is the effect on having completed secondary school, 33 percentage point more likely. Girls are 33 percentage point more likely to complete secondary school if they receive the scholarship than if they don't. This is the effect on cognitive test scores. The cognitive test scores of girls is 0.18 standard deviation, larger if they have received the scholarship than if they haven't. And so all I need to do is to divide one by the other to get the effect. So I would divide 0.185 divided by 0.33 and it's going to be approximately 0.6, a little less than. So you can play with that. You can do it for men. You can do it for years of schooling instead of completing secondary school. Or you can do it for earnings. The tables are all there in the slides. So you can do anything you're interested in. So we've seen that you can see that even a small violation of either condition for the validity of the instrument can result in a large bias. You can see it in the equation. It's because it's below. So if it's divided by something which is less than 1. So any small bias in epsilon would be blown up by the size of the first stage. So it can result in very large bias for beta. So it's pretty important to check the equation. And people tend to forget that, actually, often. Or they will only look at the first half, especially when, both with people who start from RCTs and people who start from naturally assigned variation, will be very careful to say that indeed we really have a good instrument because we have something that affects education. It also affects cognitive test scores. I'm quite confident about this estimate. So I'm confident that my reduced form is well estimated. But then they forget that intermediate link. So what I want to do before going to look at formulas is to go over some examples and say whether it seems to you to be valid or not valid. And just to make sure there is both in here. There are some that at least I think are OK, and some that I think are not OK. So here's the first example. That's from a real paper by Guido Imbens. Doctors are randomly selected to receive advice to remind their patient that it's flu season and they should take a flu shot. I use it as an instrument for taking the flu shot on sick days, for the impact of taking the flu shot on sick days. So that's often called an encouragement design. Basically, my randomized variation is this letter that I send to the doctors, and I want to use the receiving letter. The doctor has received the letter as an instrument for I have received the flu shot, and then my final outcome will be sick days. So is it valid? Is it a good instrument or not a good instrument?
If the doctor reminds a patient to take the flu shot, then there could be a way that the patient takes less sick days because they feel confident that they have a doctor looking after them. I don't know.
So that could be one. What would be a less stretchy one? Yeah.
If you tell a doctor to remind their patient, unless it's like, oh, don't call them up, if the patient is there for another reason and they remind them, oh, hey, you need to take the flu shot, but the patient is already sick for reasons unrelated to the flu shot because they went to the doctor and were reminded.
Yeah, so that would be fine because it is still the case that if the patients have come anyway, and it's patients that tend to be sick that will come anyway, it is still randomly assigned whether or not the doctor has the letter or not. So that's it's in this pool of reasonably sick people. So at the time where they went to the patient. So
sick days, for instance, would just be the people who had gone to the doctor.
Yeah, it would be it would be in this set. Yeah. Even if we took the whole set, the instrument might be weak in the sense that you might not have very high predictive power because lots of people didn't go. But as long as we select a sample where there is actually effective variation, so you've gone to the doctor once, but your doctor has that letter or doesn't have that letter. So the pool is good, comparable. Yep.
I don't know whether if you're told, oh, it's flu season, you should get your flu shot, and you're thinking about calling in sick, you feel like, oh, well, it's flu season. So that like make you more likely to call in sick because you're like, oh, like I guess lots of people are sick.
So that could be one. I would still put it in the stretchy one, but maybe a little less stretchy. Yeah.
I think that in flu season you have to get a lot of reminders anyway. Even if your doctor wasn't assigned to remind you, you just see. I mean, I know an MIT is supposed to.
Yeah.
So that would affect how effective your instrument.
Yes, exactly. So we might not have a first stage. So the nice thing is we're going to be able to see that. So if we don't have a first stage, we don't have a first stage. So that's, yep.
Is there something to be said about doctors actually following your advice? Like, would you need to measure, okay, and how often doctors follow my advice.
Yes, so they might so exactly that will also affect the first stage. They might or might not follow your advice. So that's if they don't, which doctors are no not to, then that would also make the first stage weaker. We'll be able to check that by the first stage. Yeah.
What if like the doctors you randomly select, you advise them to do this, like they don't follow your advice anyway? Like I feel like doctors are always told to tell their
Yes, so then you wouldn't have a first stage. So for all of these reasons, it might not be such. The first stage might not be very large, or might not be there at all. So if it's not there at all, you just go home and do something else. But if it's not very large, you might still be tempted to use it. And then we really need to make sure that there is no other violation. So you've tried, and then the stretchy ones are stretchy, but they had the right idea, which is there an effect? Is there an effect of the letter over and above the fact that it leads some people to get the vaccines? And what they show in that paper is that there is an effect of the letter, which is the doctors also say, by the way, it's flu season, remember to take orange juice and wash your hands often, and all of these things. So all of these things might make people less sick, not just with the flu, but with other things. They might be less likely to get the common cold or pneumonia or whatnot that are not the flu. And any of these things will affect the outcome, sick days, not through the flu vaccines, but through these other things. And in particular, if it's compounded by the fact that the first stage is not very large, then we would kind of mistakenly attribute all of this reduction, which is due to any number of causes, to just the flu shot, which would lead to bias. I want to follow up on that charter school example. So in Boston and many other places, there are too many kids who want to go to charter school, and there are not enough charter schools. So when a kid applies to charter school, the schools have to randomize who they take in. So some kids, so suppose you want to look at the impact and then suppose you want to look at the impact of going to charter school. You could say, well, I'm going to focus on the kids who have applied to this school, and use the lottery, assume the lottery was well run, to look at the impact of going to charter school. How does that look? You like it? Any opposition? Any? Yeah.
What context are we using it?
In Boston, for example, charter schools are oversubscribed, so they have to randomize. They have to run a lottery.
And we are using it as an instrument.
We're using winning the lottery as an instrument for attending a particular charter school or charter school in general. Yep.
To clarify, are the two groups you're looking at the kids who wind up at charter school and the kids who entered the lottery but didn't? Or
no, we are going to look at, yeah, exactly. We are going to look at the kids, all of the kids who apply to charter school. Either think, for example, at a particular one, makes the thinking easier. Imagine a particular, all of the kids who apply to Bridge Academy. Bridge Academy is oversubscribed every year. Who gets, not Bridge, it's called, Bridge is what let's assume Bridge Academy. Yeah. Then all of the kids apply, then some of them get in, some of them don't get in by lottery, and I'm comparing the people who win the lottery to people who lose the lottery. Yeah.
The students who apply are not represented of our population.
Yes.
Either because knowledge of the charter school or just generally more confidence that they'd be able to succeed or get in, as opposed to people from, or as opposed to students from more disadvantaged backgrounds thinking there's no point in applying.
Yes, so this is related to the question we had before. If it gives me a causal effect, it's going to give me the causal effect for the pool of applicants, which may or may not be representative of the larger pool. That is life. That's kind of what we have with samples. Like that's the sample. So we'll just take that as as given. But that's a very good point, and that's something that has been leveled as a criticism against all of these studies.
The students who lose lottery, there might be some psychological effect because they didn't get into the school, so then their underperformance in non-charter school isn't linked to the fact that they didn't go to charter school. It's linked to the fact that psychologically it was difficult.
Yes, so this is kind of back to exactly what sort of the point about winning the lottery might make you happy, and in here, like losing the lottery might make you depressed. So that might be an issue. Other than that, it seems to me to be a pretty good instrument, and actually it's been used frequently. I think that needs to be taken into consideration, and the fact that it's a specific set of kids also have to be taken into consideration, but I don't see a big issue with those at all. In fact, Josh Angris and Parag Pathak, both from the departments, are working with those a lot. So that one would be, I think, largely okay with your caveat. Another one is kids are in schools that are randomly, kids are in school and, hold on, the sentence is not very well constructed. So yes, kids, it's a study that is randomized at the school level, and kids are either in a school that is assigned to receive the pill or not. But not every kid actually gets the pill because they were absent on this day or something like that. So let's say only some of the kids actually get the deworming pill and others don't. So first I estimate the effect of being a deworming school on my cognitive scores, present in school, later earnings, whatever you're interested in. But then I say, well, let me actually instrument this. This is not the effect of being dewormed because only about half the kids end up being dewormed. So let me use the fact that I was in a deworming school as an instrument for actually being dewormed. In other words, I'm going to multiply all my estimates by 2. Yeah.
Wouldn't you need some kind of variable to control for, okay, if the school is dewormed, what percentage of students are actually there that day?
Yeah. So suppose I know it. Suppose I know for every, I have an individual level data set where I know whether the kid was actually dewormed and whether they are in a deworming school. And I don't, so I know, so I can calculate for each school the fraction of kids who actually was dewormed, or I can calculate for the entire treatment school what fraction of the treatment kids actually got dewormed. And let's say no one got dewormed in the control school. Then I have enough to do my reduced form and my first stage.
So to clarify, like when we say dewormed, do we just mean they got the pill,
they got the pill.
They don't have any worms in?
They got the pill. That's the effect. Suppose that's what we are interested in. We think, which is actually 1 for 1 because the pill are pretty. Yeah.
You get the worm, you get the pill, and you're dewormed, but you don't measure it like immediately then, and then some kid who wasn't there that day when they were giving out pills comes back and it's highly contagious and gives you the worms again.
Exactly. So that would be the problem, which is that, or on the other end, even the kids who did not get the pill actually get much better if they are in a school with other kids who get dewormed, simply because worms are so contagious that if you have worms, you'll give them to the neighbors. And therefore, being in a treatment school has an effect irrespective of whether I got treated myself, because worms are contagious. So that would not be okay here. It's pretty clear. It's an example. Any example with externalities, etc., are examples that are going to violate that link, because there is a direct effect of being in a treatment school on getting the pill. Yep.
So you asked me to keep the laptop example in mind.
Yes, I want to go back to the laptop example. So now think of the laptop. Think of the laptop example. Would it be a good instrument providing the laptops? So why would not be a good instrument?
Feels like there are a lot of externalities associated with it. For external effects, like it's not just affecting education. There's also a bunch of effects on how much time do you spend on a laptop as opposed to studying.
Exactly. It might make you spend more time might be more likely that you actually go to school and stay in school, doesn't drop out, but also it might help you study, it might hinder your studies, it might do all sorts of stuff directly, so laptop would not be a great example. Which are the ones that we went over? Sorry, go ahead. Yeah, yes.
Oh, just if you have a school where only a few kids have laptops, they're going to share them with the other students.
Yeah, and there might also be, if we randomize these laptops at the individual level, there might be an effect on the other kids, so that will create extra problems. Yeah.
So to address those two issues, what if we just gave them a laptop with really like hard-coded functions, like you can only do X, Y, Z on it, they're all educational? Would that solve some of the externalities of like in terms of effect?
Would it or would it not? For the effect, it would make sure it doesn't hurt them, but it would presumably help them. In fact, the channel through which you would have kids more likely to stay in school is that they will understand their lessons better and the like. So you will have two effects going on from the laptop. You will have kids stay in school for longer, but also, if you want, the quality of their education improves. So it would still not be a good instrument. It might be a better program, but it would still not be a good instrument for going to school. It might be a fine instrument if you're interested in the effect of cognitive scores on future earnings. You might say, well, the laptop, really the only thing they did is to increase cognitive scores. Then you could use it as an instrument for cognitive scores. Yeah.
You also talked about meals. So in that case, meals would also be problematic because they might be of different nutrition levels than what kids would get otherwise. So.
Exactly. So meals is another example that would be problematic. Certainly would bring a lot of kids to school, but it would also put something in their stomach. Typically, the meals have vitamins and iron and the like. It'll make the kids more alert. During the school day, they will learn better, and we will have these effects mushed up. Exactly. So meals would be another one. Thank you. That's.
So in that case, could we have a direct estimation of having meals on?
Exactly. Same thing with the laptops, by the way. Nothing prevents you from looking at the effect of laptop on test scores, but you wouldn't want to do the IV. All it says is that's going to give you a very good estimate of laptop on test scores or meals on test score. That's pretty interesting, but you can't extrapolate from that that's the effect of education. Sometimes you can, sometimes you cannot. So in this case, I don't think this would be a problem because these are interventions that we'd be interested in anyway. In other cases, it might be a problem because they're not so interesting intervention. You just use them as a way of getting more education. But that's always the thing we have to go through. So I mentioned at the beginning, and we already had some sort of circled around this issue, is that in reality, often we are not really willing to make the assumption that the effect of going to school on test scores is constant, for example. So ideally, we would like a sort of little I next to the beta I. So as we know, we are not going to be able to estimate the causal effect for each person. If we simply look at the reduced form effect, we know the interpretation of it. It's still the average treatment effect. But in this case, the simple calculation we did to get to show that that beta is in fact the effect of going to school on test scores doesn't apply anymore. So what can we do? So it turned out that the Val estimate is still as a causal interpretation under a fairly additional mild assumption, which I'll discuss which I'll show you to you in a moment. In that case, what the Val estimate does, or the IV estimate when we go to IV estimate, is that it captures the effect of the treatment on those who are compelled by the instrument to get treated. So we call that the local average treatment effect, or LATE. Just in case that is like, what? So what doesn't refer to the LATE thing, or what refers to, what did I just say? So let's go back to our school example and consider the 1-0 decision of going to high school or not. In principle, you can have 4 groups of kids. You can have the kids who would go to high school anyway. So in fact, we know what fraction we have. We have some kids who went anyway. You have the kids, and we are going to call those the always takers. They will go to school regardless. They'll figure it out. Okay. We could have the kids who would not go to high school even when they are offered a scholarship. So this is our bunch. There are very few among boys. We saw that most of them went. But among girls, there are many people who just decline the offer of scholarship and don't go. Let's call this one the never takers. Regardless, they're not going to take the treatment. And then there are a group of kids who would go if they are offered a scholarship, but they would not go if they are not offered a scholarship. Call these guys the compliers. They are complying to your treatment. And then we have a fourth group of kids. What is this fourth group of kids?
Those who don't go with offer?
Yes, those who don't go is offer but would have gone otherwise, who are spiteful. So those who would not go if offered, but so the opposite. So they not go. Not go if offered, but go if not offered. So please correct that in your notes. Those are the defiers. So that group is kind of weird. So my assumption, so the relatively mild assumption, sometimes it's not mild, but in most cases it's relatively mild, but it's an assumption. Assume it doesn't exist. Okay, assume there are no defiers. In that case, you can write a few lines of algebra that I will spare you to prove that the Val estimate is the effect of the treatment for the compliers. The intuition is very easy, and the trick to the proof is very easy, is that the first stage for the other two groups are 0, and you assume that group doesn't exist, so the first stage is entirely kind of moving these guys out, and therefore we have the effect for them. So to the point that you both made, which is when I look, for example, at kids who qualify for secondary school anywhere, or when I look at kids who apply to charter school, you have to make one additional comment, which is important, which is within this group, I'm not even getting the causal effect for all of them. I'm getting the causal effect for the type of kids who is moved by me. So with a charter school, for example, some kids are very determined. And if they don't get in, they will camp, their parents or themselves will camp out next to the principal office until they get a spot. So these most motivated of the motivated will get it anywhere. And then they're not part of it. So maybe the effect is still not for the most motivated of the lot. There are very few, in the case of charter school, there are very few never takers, because once people apply, presumably they are planning to go. In our case, it's the same thing. The kids who manage to scrap the money anywhere are presumably quite motivated. So my group is this kind of either the poorest of the kids. And so the question you have to ask whenever you do an IV is it a group that I'm interested in? Because you know they exist, you know what the fraction, but you don't know who they are in your sample. Nothing tells you that someone is an always taker or not, because you don't know what would have happened to them if they had not received the scholarship. You just know it one way. So the question is the group that is in general of interest or not particularly, and that has to be argued. In a lot of cases, it happens to be the group we are interested in with an instrument, because we are sort of, the instruments are often of the form that you are facilitated some group to get the thing. So, for example, in the case of scholarship, they are the people who are moved by my instrument, by having free school to actually go to school. So consider a government. What could be their policy to improve secondary school? Well, it could be to make it cheaper. So the type of people who would go to school because of that policy would be very much like the type of people who go to school because of my instrument. So that would be nice. But when you're using very exotic instrument, which happens more with using natural variation as source of instrument, sometimes we're like, well, do we care about these people? Like, that doesn't really, and is their treatment effect, okay, I know as I have an excellent estimate of the causal effect for them, but that might not be representative of the causal effect for the rest of the world, and I'm not so interested in them. So that's the type of question that you have to ask yourself. So why don't we stop here, and then we'll take up exactly from there on Wednesday before going to experimental design, going over the formula, linking it to two-stage least square more generally, okay?